All right, so just the first 3 slides of this are P1. I didn't do all of the stuff from P1. There was a lot of different stuff, but here's some 3 of the examples, and then we'll get into P2. And then before class is over, we need to talk about your like your test and your makeup if you're taking the AP, but I'll get to that at the end. Just don't let me forget. Okay, so this one just says solve the equation. This is where we've got fractions in our denominators. So the first thing we would do is look to see if we can factor it to figure out what the least common denominator is. There's no factoring here, but these are different factors, which means when I multiply, the least common denominator is both 2x plus 1 and 2x minus 1. So I'm going to multiply that times all 3 terms, plus 1, minus 1, in my equation. And I said it the other day, but I'll say it again, that the biggest mistake people make is not remembering to go across the equal sign on these. So make sure you do all of the terms. So from the first one, the x plus 1's cancel, but I end up with 7 2x minus 1. From the second one, the minus 1's cancel, but I have a negative 8x, so be careful with that negative because it's got to get distributed, and then 2x plus 1. And then from the last one, you've got both of them. So I would distribute this 7 in on the first, it's 14x minus 7. Distribute the negative 8x here, and it's negative 16x squared minus 8x. And then if I FOIL this out, you can actually do it in a couple different ways, but I'm going to FOIL this out first and then distribute in the negative 4. I'd get negative 4. This is the difference of 2 squares. So it becomes 4x squared minus 1. That's what you would get if you did first, last, outer, like the first outer, inner, last. And then I would have to distribute in this negative 4. So I'm going to combine my terms on the left side and distribute on the right side. So negative 16x squared plus 6x minus 7 equals, distribute this, negative 16x squared plus 4. Now I want to get both the x squared to the same side. If I add 16x squared and 16x squared, they actually cancel, and I get 6x minus 7 equals 4. Add the 7, 6x equals 11. Divide by 6, and x is 11 over 6, or 1 and 5/6. Either of those answers is fine. But remember that this has a fraction in its denominator to begin with, so we have to check to make sure that when we plug that answer back in, it doesn't give us a 0 here or here. The only thing that's going to give us a 0 in those places are positive or negative a half, so we are good. If you want to plug it back in to check, you can. Like if I did 2 times 11 sixths plus 1, it'd be 11 thirds plus 1, which is not 0. And 2 times 11 sixths minus 1 is 11 thirds minus 1, which is again not 0. So I know that this answer can be kept. If this is open-ended, well, it probably won't be open-ended, but if it was open-ended, it would say write it as one improper fraction. So it'd be 11/6. If it's multiple choice, just realize both of those answers are right. One of them will be there and one of them won't. So you know which one to pick. Questions on that one? Okay. Second question, quadratic formula. So we've got negative b plus and minus this b squared, square root, b squared minus 4ac all over 2a. Before we can plug that in, we have to identify a is 16, b is negative 40, and c is 5. So I get negative 40, which is 40, plus and minus the square root of negative 40 squared minus 4 times a times c all over 2 times a. So I get 40 plus and minus the square root of 1600 minus 320 over 32. 1600 minus 320, 1280 over 32. So now this time it's not a perfect square, so I have to see if I can break that down. And obviously this is a number that can get broken down. So we want to break it down into its factors. I can say 10 and 128. 10 is 2 and 5, 128, 2 and 64. I can keep going. I could have made that 8 and 8. That's fine. But let's say 2 and 32, 2 and 16, 2 and 8, 2, 4, 2, 2. Now for each pair of 2's, 1, 2 goes to the outside of my square root. So here's one pair, so I've got 40, plus and minus. It would be 2 times, there's another pair of 2's, times another pair of 2's, times another pair of 2's. The only thing left underneath is that 5. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 16 root 5 over 32. Now you can either split and reduce it or reduce it here and then try to split it. Either way you end up, these are all divisible by 8, so this would be 5, 2, and 4. 5 plus and minus 2 root 5 over 4. If this is a question on your test, because that format's so tricky, it would be multiple choice, and the answer will either be left this way, or if you split it, you can actually simplify it further. And it would look like that. Or it will be split like 5/4 plus 1/2, 5, comma, 5/4 minus 1/2 pi, or root 5 over 2. So there will be some sort of format like that. Questions on that one? Okay, last one from this section is that third one, which says x plus 5 to the 3 halves equals 27. So this is our exponential fraction, okay? In order to get rid of that exponent, we are going to raise both sides to the reciprocal of that fractional exponent. Okay, so we raise it to the reciprocal, and by doing that, we cancel the left side, right? 3 halves and 2/3 would cancel out. So I get x plus 5 on the left equals 27 to the 2/3, which is the same thing as the cube root of 27 squared. The cube root of 27 is 3, and 3 squared is 9. So this becomes 5. X plus 5 equals 9. And then just subtract the 5, and I get x equals 4. Because my original question has a square root in it, so the bottom number remembers the index. Because an original question has a square root in it, I have to check this answer to see that I wouldn't be trying to square root a negative number. So I plug the 4 back in, and I'd get 4 plus 5. I would square root that and then raise it to the 3rd power. All I need to know is this negative? 9's not negative, so I know this is okay. And my answer would be x plus 4. Questions on that one? So there were other types of questions in this homework. Obviously, you're responsible for all of it. This is just the you know, those 3. We will go back over a review before your test. But just keep in mind that all P1 was all those different kinds of solving. Okay, homework answers, remember, are on Calc Chat. So when you go into Calc Chat, this time P2. So P2 is inequalities, okay? Solving inequalities and then graphing them on the number line. If you remember inequalities, again, something you've done since, like, you know, algebra since middle school probably. They just get a little bit more complicated as the years go by. So the first thing is that we solve them just like equations, except for 2 scenarios, when we divide or multiply both sides of the equation by a negative number. If that happens, then we flip the sign. Okay, so if that happens, We flip the sign. So if it was less than, it becomes greater than. If it was less than or equal to, it becomes greater than or equal to. If the other way around, we flip it. Only if you divide or multiply by a negative on both sides of the equations, though. Not like if you're just simplifying and there's a negative involved. So, for example, if I wanted to graph, it's going to say solve and then graph. So if I want to graph these solutions, let's say I've gotten to the point, oh, let me group that. Let's say I've gotten to the point where I've already solved it. And now I want to graph it. We've done two different ways. If you remember, we did inequalities that had brackets, parentheses, and then open dots and solid dots. So this is like an open dot. An open dot parentheses is, open dot and parentheses are the same thing. Solid dot and brackets are the same thing. When we get into like Algebra 2 regular book uses open dot and closed dot. And then when you start to get into pre-calc, they switch it into parentheses and brackets so that you can use interval notation as solutions. So just keep that in mind, okay? So if it said x, if my answer was x is greater than -3, then I would plot my number line. You just really need 3 numbers to establish your orientation. -3 in the middle, and then one smaller and one bigger. And because it's greater than and not greater than or equal to, it would be a parentheses pointing toward the right. If it was a x is less than 2, like the next one, again, you want to put 3 numbers, so 2 in the middle, 1 less than, 1 bigger than. Less than is going to be a parentheses pointing to the left. And then we get less than or equal to, I'm sorry, greater than or equal to. So greater than or equal to, again, it's 3, so I'm going to put 3 in the middle, 2 and 4. Greater than or equal to is now a bracket. So this gets a bracket and shade to the right. And less than or equal to 4 would be 3, 4, 5. Less than or equal to gets a bracket on the 4, shade to the left. So all of these questions are going to say solve it and then graph your solution on a number line, and that's what that means. Okay, so example 1 says solve the inequality and then sketch the solution on the real number line. So we are going to have just simple inequalities, obviously, but then you've got ones with fractions. And so we want to do the same thing that we did the last time, is get rid of that fraction. It's the easiest thing to do from the beginning. So if you look here, there's only one fraction. The denominator is 4, so I'm going to take and multiply everything by 4. So every term gets 4 except for what's inside the parentheses. That's protected by what's on the outside. It's going to get distributed there. So I'm going to do 4 times 9, which is 36x. I'm going to do 4 times -1, -4. Less than, the 4's would cancel, and it's just 3, 16x minus 2. Now I want to distribute the 3, so 36x minus 4 is less than 3 times 16, or 48x minus 6. I want to get both the x's to the same side, so I'm going to subtract the 36x. And I'm going to add the 6. So I get 2 is less than 12x. Divide both sides by 12. And I get x is greater than 1/6, or 2/12 simplified. So now we always want to reverse the order of the lettering so that the x comes first, but the big part of the inequality still has to open towards the x. So there's my answer. X is greater than 1/6 is the solution, but then I want to graph it on the number line. So I'm going to draw my number line. 1/6 would be in between 0 and 1. It doesn't have to be exactly in between. It's fine. Greater than is a parentheses pointing toward the right. Questions on that one? All right, example 2 is a compound inequality. Compound means it has two inequality symbols, okay, in one statement. So for these, when there's a compound one with obviously the variable in the middle, this is going to be an and statement. So it's going to be that the x is bigger than something but less than something. There's two parts to it. Whatever's done to the middle has to be done to both sides. So if you add or subtract to the middle, you have to add or subtract the same thing on the outside. If you multiply, you have to do it times all three parts. So I don't know why there's the C there. Ignore that. You just need the A. Okay, it says solve the inequality, sketch the solution on the real number line. So we definitely have a compound inequality. There's two inequality symbols. So the first thing I would do is get rid of the negative that's on the front of the parentheses. This is either by dividing or multiplying by -1. And when we do that, all the signs are changing direction. So this becomes 8 greater than or equal to 3x plus 5, because these have canceled, greater than -13. So all the inequality signs changed. Notice that this one has an or equal to, this one doesn't. That's fine. That just determines what's going to happen on the end when I graph it. Now I want to subtract the 5 from all three parts. I get 3 greater than or equal to 3x, which is greater than -18. Divide by 3, all three parts, and I get 1 greater than or equal to x, greater than -6. So I want this to be in order from smallest to largest, so it makes sense and matches the order on my number line. -6 is clearly smaller than 1, so I'm going to reverse the order here. -6, the big part still has to point towards x, so it's going to look like this now. And the small part on the last one has to point towards x, so it's going to look like this. So -6 is less than x, which is less than or equal to 1. Now I go to my number line. -6, -5, -4, -3, -2, -1, 0, and 1. Fix this side so you can see that a little bit better. Okay, so it is greater than -6, which means it gets a parentheses on -6, and I'm going to point it to the right. But it is less than or equal to 1, which means it gets a bracket on the 1. And then I would shade everything in between. So that's what a compound and statement looks like. You're going to have two ends, whether they be parentheses or brackets will depend on your statement. And then you're going to shade in between. Everybody still doing okay? Hang on, wait a minute. Say that again, Bianca. Yeah, you'll see when we get into like absolute value and quadratic, it can change, but these ones that are like just your standard statements that have that variable in the middle will always be shaded in between. Yeah, there's a couple special cases which we'll get to, but for just your general statement like that, it will always be shaded in between. All right, so that's where these come in. These are the absolute value inequalities. This is where it gets a little bit trickier. So absolute value inequalities, there's two different types. First thing you have to do is get the absolute value on the side by itself. So first step, get absolute value alone. So you want just the absolute value on the side by itself. Then you want to read it in your head or out loud, whatever you need to do. But if that absolute value is read as absolute value of something is less than x, it's less than the number, so the variable will be inside the absolute value. If the absolute value is less than a number, then it becomes an and statement, which is like we just did. But you have to create the and statement. You're going to take the positive number that's on the right, put it on the left, and make it one big and statement, which I'll show you what that looks like in a minute. If the absolute value of whatever the variable is greater than what's on the right, then it becomes an or statement. So you're still going to take the positive number that's on the right and you're going to put it on the left, but you're going to split it into two statements. So the or becomes two statements that are separate. Your arrows will point out. And the and is one statement that stays just the way, just like the one we just did. So if you say the word less than, you actually like think and ends the same way, and great or has or in it. So hopefully that reminds you that that's or, okay? So you can always say it that way. When you're looking at the examples that are here, so if I look at the very first one, first of all, same set of instructions. Solve the inequality, sketch the solution on the real number line. If I look at A, the absolute value is already on the side by itself. If it wasn't, if it was like a +3 here, I'd move the 3 first, because that could actually change it from an and to an or. So you want to make sure it's on the side by itself first, which this case it is. And if you read this out loud, this is absolute value of x minus 7 is less than, which means this is an and, 5. So I take off my absolute value. It goes back to the rules on absolute value. Remember, whatever's inside the absolute value is equal to the positive and negative version of that number. The difference is we don't do equal. We would do -5 is the same direction sign, so is less than x minus 7, which is less than +5. So we take this number, we change it to be negative, and we push it to the front of our statement. Now we just made this an and statement because the x is in the middle. It's bigger than the left, but smaller than the right. So then I just want to add the 7 to both parts. And I get 2 is less than x, which is less than 12. There's my solution. There's my inequality statement. Now I need to graph it. So 2, I'm going to go by 2, 4, 6, 8, 10, 12. Parentheses on the 2, parentheses on the 12, shaded in between. So again, if the absolute value is less than the number, it becomes an and statement. Take the negative from the right, or take the positive from the right, put it to the left. And now you've created yourself a compound inequality. That's an and statement. Questions on that one? All right, just like almost everything else, there are some special cases. So there's like things you got to look for. If you look at B, it actually says the absolute value of x minus 7 is less than -5. So what's true about everything that comes out of an absolute value? It has to have what sign? It has to be positive, right? What kind of sign would be something that's less than -5? It's negative, right? Can a positive number ever be less than -5? No. So this is no solution. So the special case here that you can catch from the beginning is the absolute value can't be less than 0. So it can't be less than 0. It can't be less than a negative number. It can't be any of those things. It can be less than or equal to, because you can find one solution there. But it can't be less than or equal to a negative number, and it can't be less than 0. Okay, last one is C on this slide. And it says absolute value of 2x minus 7 is greater than or equal to 5. Think about how I just said that. Great or, right? So great or means it's an or statement. So I almost do the same thing. I take the -5. I put it on the left. I keep the sign going in the same direction. But I have to make two statements. So if I did this, my arrows are going to be really weird. It's going to get confusing because they have to point out. Which means we say or 2x minus 7 is greater than or equal to 5. So we took the 5 that's here, whatever number's there, we make it negative, we put it to the left, but we split them and make it an or statement because there's two different directions happening here. So I add the 7 to, I'm still doing the same steps. This is 2 greater than or equal to x, 2 greater than or equal to 12, and then divide by 2, all the parts. And I get x is less than or equal to 1. X is greater than or equal to 6. Notice the signs are pointing in the x is on the wrong side of the left. So I want to switch this around so that it's x is less than or equal to 1. Or, because that's what's part of here, x is greater than or equal to 6. So now 1, 2, 3, 4, 5, 6, or equal to means bracket. Bracket on the 1 pointing to the left, bracket on the 6 pointing to the right. Questions on that one? All right, last type is quadratics with quadratics with inequalities. These are the ones that are a pain in the butt because you got to do a test solutions. You got to plot your points, test them, and figure out what works. So you're going to solve the quadratic as if it was equal to 0. So the first thing we're going to do is actually change that inequality to an equal, solve it as though it was 0, which means even root property or factoring. Then we're going to set up a number line and test points. You're going to, everywhere there's a solution, give yourself like a little range. You're going to plug in a point from the left of that range, in between to the right. And I'll show you what that looks like, okay? And then from there you determine your solutions. So same set of instructions, solve the inequality, sketch the solution on the real number line. A says x squared equals, or is less than or equal to 16. So I'm going to make it x squared equals 16. You can either move the 16, factor it, or you can use even root property to say that it's plus and minus the square root of 16, which means plus and minus 4. How you solve it's up to you, but that's where my test points come from. So now I go to my number line, and I'm going to do -4, I'm going to do +4. Almost all the time, there's going to be two solutions. Sometimes it happens that there's the same solution twice, but you should always have two solutions, unless it was equal to 0. Which means there's 3 ranges here. There's left of -4, there's in between -4 and +4, and there's right of +4. And you have to pick a point from each range, plug it into your original equation, and determine if it's true or not. If it's true, that range is part of your solution set. If it's false, then it's not part of your solution set. So we're going to just pick a number from -4 to -infinity, which means like -5. In between -4 and +4, maybe 0. I would always choose 0 from the range if it's there. And then bigger than 4, like 5. And plug them each in here. So -5 squared is less than or equal to 16 gives me 25 is less than or equal to 16, which is not true. So I rule out that range. Then I go 0. 0 squared is less than or equal to 16. 0 is less than or equal to 16. So I know that range is part of my answer. And test 5. 5 squared is less than or equal to 16. 25 is not less than or equal to 16. So I know I rule out the right side. Now, normally it's either the center or it's the outsides. There are special cases, and those are when there's a repeated root. So always test. So now I know that my answer is actually from -4 less than or equal to +4. And my solution would be from -4 to +4. Bracket on both, shaded in between. Questions on that one? All right, next one. Again, we're going to say first it equals 1. We're going to square root both sides, putting a plus and minus on the right hand side. I get x minus 3 equals plus and minus 1, which means x minus 3 equals -1, and x minus 3 equals +1. Add the 3, x equals 2. Add the 3, x equals 4. So those are the 2 points I'm going to use to set up my range, 2 and 4. I'm going to plug in something from the left of 2, like 0, in between 2 and 4, like 3, and bigger than 4, like 5. I'm going to plug it back into the original one, which is x minus 3 squared is greater than or equal to 1. So 0 minus 3 squared greater than or equal to 1. Negative 3 squared greater than or equal to 1. 9 is greater than or equal to 1. So this section works. Which means I assume the 3 is going to fail. 0 squared is not greater than or equal to 1. So the 3 does not work. And the 5 and that works. So that tells me that my solution is that x is less than 2 or greater than 4. And my solution on a number line is going to be a parentheses on the 2 pointing to the left and a parentheses on the 4 pointing towards the right. Alright, last one, x squared minus 6x plus 9 is less than 16. As soon as you see the x squared and the x, hopefully this is your cue that you're going to have to factor. So I'm going to move this 16 onto the side with the 9, subtract this, and I get x squared minus 6x minus 7 is less than 0. So the first thing I'm going to do is pretend like it's 0, right? Equal to 0. I'm going to factor this, x minus 7, x plus 1. Which means that my 2 answers that I'm going to use to set up my test points are 7 and negative 1. Actually, let me erase this. Okay, so these are our sections, right? So I need a point from the left of negative 1, which would be like negative 2, a point in between negative 1 and 7, like 0, and a point bigger than 7, like 8. Now you can actually plug it into here, or you can plug it into here, or you can plug it into here. Whatever's easier. I usually pick the one that's already like everything's moved over to one side so that 0 is the only thing left. You can plug it into any of those spaces. So I'm going to use this second one here. This one. X squared minus 6x minus 7 is less than or equal to 0. And I'm going to plug negative 2 in. So I get 4 plus 12 minus 7 is 16 minus 7, which is 9. That is not less than 0. So I rule that section out. Go to the middle, 0 minus 7. Negative 7 is less than or equal to 0. So that works. 64, I'm assuming this one's not going to work. Which is 9. Does not work. Which means my solution set is in here. It's greater than or equal to, so it gets a bracket. So from negative, we'll write on it. All right, so it's a less than, right? So it gets negative 1 is less than x, which is less than 7. And then my number line from negative 1 to 7, parentheses on both, shaded in between.